Okay, so the second order condition for a maximum function fx requires. Okay, so let me just show you a diagram for this second order condition. Okay, so it usually deals with quadratic equations where you have a parabola. All right, so as you can see here, what happens is you'll be given a function. Okay, so first thing that you need to do is you need to derive that function. Have you seen this f prime x 0 equals 0, and here this f prime x equals 0? What it just says that whatever function you're given, you need to derive it. Okay. Then, if you want to know if your function is a minimum or a maximum, meaning if it has a maximum, it means it's a concave downward parabola. If it's a minimum, it's a concave upward parabola, right? So for a maximum, when you derive your function the second time and you plug in your x value, if it's less than 0, then you have a maximum. But if it's greater than 0, when you do your second derivative and then you plug it into your function and your value is greater than 0, it's a minimum. So in this question here, for a maximum function, it's this one. F prime of x equals 0. Then the second derivative, when you plug in your value, it should be less than 0. So our answer here is 10. Well, number 10 is B. Any questions before we go to number 11? Okay, so the following figures show the demand and supply functions for Salawula jeans at Soweto Market and possible directional changes identified by unique arrows. Use the figure to answer questions 11, 12, 13, 14, and 15. So we can see here, figure 1, arrow here, what it's meaning is when the demand curve shifts to the right. Okay, when the demand curve, see if anyone else coming in. Okay. This arrow 1 is just showing when the demand curve shifts to the right. Okay. Arrow 4, supply curve when it shifts to the right. Arrow 3, demand curve when it shifts to the left. And arrow 2, the supply curve if it shifts to the left. So, which of the following lines depicts a typical demand function? It is this line here, line 5. Okay. Remember, a demand function is downward sloping due to the law of demand. Okay. Due to the law of demand, the demand curve is downward sloping. So the demand function here is line 5. Any questions? So 11A. Number 12. Which of the following depicts a downward change in the demand function for the commodity? Okay, so a downward change means demand is dropping. Okay, demand is dropping like this. When demand shifts like this, that's a downward change in demand. And so it's being represented by arrow 3. Okay, so a downward change, this one. So that represents a decrease in demand. Then which arrow depicts an increase in demand? So when demand increases, it shifts like this. Okay. So arrow number 1 is showing an increase in demand. Okay. So for this one, arrow 1. So we're going to choose A. Any questions before we go to number 14? which arrow depicts a decrease in supply. Okay, so decrease in supply, and the supply curve shifts like this. Supply curve is curve 6. So when curve 6 shifts like this, arrow 2, decrease in supply. Okay, that is arrow 2. Okay, so decrease in supply, arrow 2. Okay. So there you just need to know about this supply and demand curve. When demand increases, decreases, or supply increases or decreases. Okay. Yes. Question 15. The equilibrium at the intersection D and S is approximately P equals 30 and Q equals 17. So P equals 13 and Q equals 17. The demand increases by arrow 1. The new equilibrium will be here 17. So when demand increases by arrow 1, meaning it shifts like this. Okay. So they're asking us, so when this demand curve shifts, what we're going to notice, we're going to have an increase in price. We'll call this P2, increase in price, and we're going to have also increase in quantity. Okay, Q2 here. Okay, so the new equilibrium will have a higher price and a higher quantity. Okay, a higher price and a higher quantity. Okay, colleagues. Yes. Number 16. The law of demand states that all else equal, as price rises, quantity demanded falls. Okay, this is the law of demand here. Inverse relationship between price and quantity demanded. One goes up and the other goes down. Okay, number 17. The linear demand function for QD is 5,000 minus 10 pm plus 8 PR plus 0.5 m, where PM is the price of maize, PR is the price of rice, M is consumer income. This implies that maize and rice are, okay, so first things first, we look at our demand function here, look at the relationship of quantity demanded and the price of rice, because this demand function is for maize. So quantity demanded for maize and the price for rice. We can see there's a positive sign here, meaning if the price of rice increases, people stop buying rice and they'll start buying maize. And what will happen? Quantity demanded of maize will increase. If the price drops, people buy more rice and they'll stop buying maize. So quantity demanded of maize will rise. So one, we've seen they already complements. Okay, they're already complementary goods because of this positive sign. Okay. Then to see if it's a normal or inferior good, we look at the relationship between quantity demanded and income here. Okay. So there's a positive sign here, okay, meaning if income increases, quantity demanded of maize also increases. If income drops, quantity demanded of maize drops. So that is a normal good. That means it's a normal good. Okay. So these are complements and maize is a normal good. Okay, colleagues? Yes. Okay. The figure below shows a competitive market at equilibrium E, okay, where price is 20 kwacha and quantity is 40,000. The demand curve intercepts the price axis at 40 and the supply curve passes through the origin. Use the figure to answer questions 18 and 19. So we've got our price and our demand, the quantity. So they say consumer surplus at equilibrium. So consumer surplus, think of it as the extra benefit to the consumer. Okay, colleagues? The extra benefit to the consumer. Or is the difference between what the consumer is willing to pay minus what the consumer actually pays. That's consumer surplus. Difference between what you're willing to pay versus what you pay. Okay, so if you're willing to pay 25 kwacha for something and you actually pay, let's say, 20 kwacha, your consumer surplus is 5 kwacha. Okay, yes. So think of it also, it can also be like a saving to the consumer. Okay, colleagues? Consumer surplus can also be like a saving. Okay, yes. So that is what it is. So basically, it's just getting the area of this triangle here. You get the height, 40 minus 20, that is 20. You get the base from 0 to 40,000, the base is 40,000 here. So consumer surplus half, remember it's the area of a triangle. Consumer surplus half times B times H. In this case, H is 20, B is 40,000. Okay, yes. So you say half times 40,000 times 20. Okay, so half of 20 is 10. 10 times 40,000, 400,000. So this is the consumer surplus, 400,000. Any questions, colleagues? So consumer surplus, the saving to the customer or the extra benefit or the difference between what the consumer actually pays and what they're willing to pay. Okay. The producer surplus at equilibrium. So remember, producer surplus, also this is like the extra money the producer gets, all right? Or think of it as the difference between what a producer is willing to sell an item for versus how much they sell that item for. So if you're a producer, okay, and you want to sell maize at 20 kwacha, but you find you can sell this maize at 50 kwacha. Okay, this is what you are willing. This is the actual. 50 minus 20, 30 kwacha. This 30 kwacha is like your extra, the extra money you earn. Okay. So from consumer surplus, it's like a saving. From producer surplus, it's like an extra earning. All right. So same thing here. We have to get the area of this triangle. Okay, the height from 0 to 20, then the base 40,000. So the producer surplus is also 400,000. Okay. Yes, 400,000. That is the producer surplus. Okay. A price ceiling set below equilibrium prices causes. So remember, a price ceiling is below the equilibrium price. So I can use this one as an illustration here. Price ceiling below equilibrium price. So let's say the price ceiling is here. Okay. This is the maximum amount the sellers can sell. They can't go above this amount. They can only go below. Okay. So let's say in this market here, was it jeans that were going? Was it jeans? Yes. Wait a minute. What good is this? Okay. Let's say this is maize. Okay. Maize is going for 20 kwacha. Then government comes and says, no, we're putting in a price ceiling that maize should go for 10 kwacha. Meaning sellers cannot sell maize for more than 10 kwacha. It's either 10 kwacha or below. So a price ceiling is the maximum legal amount that a good can be sold for. Now this price ceiling, okay, it intersects the supply curve. Okay, so where it intersects the supply curve, this will be the quantity supplied. And where it intersects the demand curve, that will be the quantity demanded. So when a price ceiling is enacted, we can see that quantity demanded exceeds quantity supplied. So what happens? You have a shortage. Okay, you're going to have a shortage because this price ceiling benefits the consumers and it badly affects the producers. Okay, because after this price ceiling is put in, this is the producer surplus now. From that big triangle to this small triangle now here. Okay. Yes. Okay. So let's see our options here. So a price ceiling set below equilibrium price creates a market shortage and dead weight loss. Okay, colleagues, the dead weight loss is here. Okay. This is what could have been produced but is not produced. Okay, that's the dead weight loss. It could have been produced, but due to the price ceiling, it's not produced, so it's lost. It's wasted basically. So the dead weight loss is this triangle here. Okay. This is the dead weight loss. DWL. That's the dead weight loss. Okay. Then this whole trapezium here is now consumer surplus. So the consumer benefits more from this price ceiling than the supply. So for our answer here is B. Yes. The owned price elasticity of demand is computed as, so remember, price elasticity of demand is percent change, how quantity demanded responds to change in prices. Okay? How quantity demand demanded response to price changes. Okay, so here our best answer is B. Okay, percent change in quantity demanded over percent change in price, where PX is the goods on price. Okay, that is how we compute price elasticity of demand. Okay, if it was income elasticity of demand, this is the one. Income elasticity of demand. Okay, how quantity demanded responds to change in income. Okay, then there's cross price elasticity of demand, this one here. Okay, cross price elasticity of demand, this one shows how the quantity of one good responds to the change in the price of another good. Okay, so cross price elasticity of demand. Okay. Yes. So remember, any of these elasticities, whenever you just say elasticity of demand, if it's income elasticity of demand, how quantity demanded responds to changes in income. If it's price elasticity of demand, how the price, how quantity demanded responds to changes in price of the own good, the goods own price. If it's cross price elasticity of demand, how the quantity of good A responds to changes in price of good B. Yes. Okay, we have a question here. Market demand here is QD equals 200 minus 4P. At 25 quart, the point on price elasticity of demand is. So to get the point on price elasticity of demand, remember the derivative of the demand function with respect to P multiplied by P over Q. Okay, this is the point on price elasticity of demand. You derive this function and multiply it by P over Q. So first things first, let's find our Q here. Okay, so we've been told QD equals 200 minus 4P. So I want to find our quantity. So you substitute when P equals 25, substitute it into here. So that becomes 200 minus 4 multiplied by 25. 4 multiplied by 25 is 100. So you say 200 minus 100. That will give us 100. Okay. So when the price is 25, the quantity of units demanded will be 100. So we found our Q. Next, we need to derive this function. So we say dq dp. Okay. When we derive this 200, it disappears. All right. When we derive this negative 4p, we get negative 4. Okay, colleagues? When we derive this function here, we get negative 4. All right. So our formula becomes here negative 4 times price 25 over quantity 100. Okay, so get negative 4 multiplied by 25 divided by 100, that is 0.25. Negative 4 multiplied by 0.25, 0.25 times 4, you get negative 1. Okay, we get -1. So here answer is B. Okay. Number 23. For the demand function QD 200 minus 4P from quotient 20, total revenue is maximized at. So total revenue is maximized where marginal revenue equals 0. Okay, that's where total revenue is maximized. So first things first, we need to get our total revenue first. Total revenue equals P times Q. All right. So we have P here. Okay, then Q equals 200 minus 4P. Okay. So P times 200, 200P. Then P times negative 4P, get negative 4P squared. Yes, that is our total revenue. Then marginal revenue is the derivative of total revenue. So when you derive this 200P, it becomes 200. When you derive this negative 4P squared, it becomes negative 8P. All right. So we say total revenue is maximized where MR equals 0. So 200 minus 8P equals 0. Get the value of P. Take this negative 8P this side. So you have 200 equals 8P. To get the value of P, divide both sides by 8. 200 divided by 8, that is 25. So P equals 25. Yes. The cross price elasticity of demand for good X with respect to the price of a good Y is positive 2.5. This indicates that X and Y are, so remember, cross price elasticity of demand is positive, they are complements. Okay, they are complements. All right, so we'll say here complements. So positive 2.5 can say complements with a strong relationship. Okay. If this cross price elasticity is a negative, then they are substitutes. Okay, question 25. The income elasticity of demand for a good is negative 0.8. This good is best classified as an inferior good. Okay. A negative income elasticity of demand, inferior. Positive, normal good. Yes. Yes, I think, yeah, that finalizes section A.